Good morning, everyone. This is Siddhant Thakur, and I'm here to present uh, a short seminar over role of big data in football via an expected goals model or an XG model. So we'll first hop on to our topic. What is big data? Big data, in the most simplest of terms, is the vast amount of disparate data that enables organizations to store, manage, and manipulate it. As we can clearly see, we can break down big data into three V's: volume, how much data is present; velocity, how fast the data is processed; and variety, types of data. While it is convenient to simplify big data into three V's, it can be misleading and overly simplistic. For example, we may be managing a relatively small amount of very disparate, complex data, or we may be processing a huge volume of very simple data. So it practically depends on the context of the data. Moving on to my topic, or what I'll be discussing, how data has influenced football or sports in general. Use of data to produce or bolster decisions has been a norm in every industry that wants to have an efficacious decisiveness towards a problem statement. Similarly, even the sports industry also has been incorporating this proliferating and indispensable commodity called data. We all know about one of the most famous nonfiction books, Moneyball, which discusses about how the Oakland A's baseball team and its general manager, Billy Bean, assembled a competitive baseball team using an analytical, evidence-based, and sabermetric approach, despite Oakland's small budget. One of the most simplest and yet the most crucial way data influences sports is that data helps teams win. Well, I'm no manager, neither am I an analyst from Yale working for the A's. I'm a student with interest in data science and sports, and I just love to work on the common ground. That is why, to start off with my endeavors in sports analytics, I worked on an expected goals model. The aim of the project is to examine goal scoring in English Premier League and consequently produce insights in order to help the coaches and players to improve their attacking strategies and ultimately lead the team to a win. So, this like on coming towards the topic of data, there's not a lot of data available for football as it is mostly commercialized, and teams don't really like to have their data like open to everyone. This data set used in this project consists of all the event data, which basically means a record of all the events that were performed during the game time in a JSON format from the English Premier League for the seasons 2008 to 2018, provided by Wisecout. The shots on goal, or the data actually used for the model, were the shots on goal. They had tags of either shot or a header. So, what is XG? XG, or expected goals, is a model which is used to understand how likely a goal scoring chance will lead to a goal. Well, that's more simple and direct use. The model can be further used to give an indication of whether the results of a football team are based on sustainable factors like a steady creation of chances, good attacking strategies, or whether it is down to aspects such as luck or world class goalkeeping. XG is kind of like probability. I mean, it is probability. It ranges from 0 to 1. Higher the XG, higher the probability of scoring a goal. This is my short explanation of what actually went into the expected goals model. So, how do we find an expected goal of a shot? Well, a lot of factors can be included to get a value of or for a chance for a goal scoring opportunity. Here, we only use the angle of the shot and the distance of the shot from the goal. We can also use what position the shot was at, the defenders, the number of defenders that were in front of the goal, where the shot landed in the goal. So we can all use these factors to get the expected goals model. However, to keep the model as simple as possible, I've just taken the angle and the distance. The distance was calculated using the Euclidean formula from the location of the shot to the center of the goal, and the angle was, well, trigonometry was used. Um, so the insights from what we got, the insights that we got from the data basically includes these technically three heat maps because those were included in the exploratory data analysis and why we actually need the expected goals model. If we go from top left to bottom right, we can easily see how the same data can be processed, plotted, and simplified in order to generate insights from it. We see that the number of shots and goals around a goal post gives us an ambiguous interpretation for the likelihood of a goal being scored. If we just go with taking proportions of shots resulting in goals, we get a somewhat correct plot. However, it is still full of outliers for the shots that didn't have much frequency, and the player shooting from that position scored a goal, which they basically got lucky. Therefore, we bring in the XG model and it gives us the bottom right heat map, a good distribution and a heat map which actually shows the probability of goal being scored. Now these are the insights or results. This discusses the effect of angle and distance individually to the XG of a shot. As we can see, and it makes sense that if we increase the angle of the shot, then the XG will be much higher. Also, it obviously makes sense that we tend to score more goals if we shoot from distances closer to the goal. However, the XG model was not created just so that we can give a premise to our assumption of shooting from a closer distance. It was developed to track the attacking strength of a team. Were they getting lucky? Was the opposing keeper exceptional? And many other questions that the coaches and the attackers would like to answer. Even the defenders can use this data to actually understand the opponent's attacking strength and what other strategies they actually use. Therefore, an expected goals model is just a step closer to more utilization of data in football. Thank you.